Every time a user interacts with a modern application, their data travels toward a logical gate. This is the primary checkpoint where backend systems evaluate incoming requests to prevent unauthorized access to the database. Maintaining this checkpoint requires two distinct operations. While they are often grouped together as security, they perform very different technical roles. Authentication is the identity verification step. It answers, "Who are you?" The server compares credentials against its records. Once confirmed, it moves to authorization, defining what a user can do, like viewing their profile while restricted from administrative functions. To implement these gates effectively, developers choose from 5 core authentication architectures, each suited to different deployment environments. Confusing identity verification with permission enforcement is a common architectural error that leads directly to unauthorized data exposure. Basic authentication is the simplest method. The client encodes the username and password into a base 64 string, attaching them to the header of every HTTP request. The server intercepts the request, decodes the string, and queries the database to verify the match. Because this method involves sending credentials repeatedly, it's insecure without a mandatory HTTPS layer. Consequently, it's generally limited to simple internal scripts or legacy systems. For standard web applications, developers traditionally used session-based authentication to avoid sending passwords with every request. Here, the user logs in once. The server verifies the credentials and creates a unique session ID, which it stores in its own memory. This session ID is sent back to the client's browser, which stores it inside a cookie. The browser automatically includes this cookie in all future requests, allowing the system to recognize the user. This is a stateful architecture. As the number of users grows, the server's memory fills up, creating significant resource overhead. This stateful model becomes difficult to manage when an application is distributed across multiple servers, as each server needs access to the same session data to recognize the user. To scale a backend efficiently across multiple nodes, the server needs a way to verify identity without storing local session data. It needs to be stateless. JSON Web Tokens, or JWTs, provide this stateless solution. They have become the standard for modern REST APIs and mobile applications. When a user logs in, the server verifies the credentials, but does not save a session. Instead, it generates a JWT, a cryptographically signed string. This token is self-contained. It contains the user's identity and an expiration timestamp, all encoded within the string itself. The client receives this token and stores it locally, typically in local storage or a secure cookie. For subsequent requests, the client includes this token in the authorization header as a bearer token. To verify the request, the server applies a secret key. This mathematical verification confirms the token hasn't been tampered with, all without needing a database lookup. Because verification happens in memory using cryptography, the system avoids the latency and storage requirements of session databases. The trade-off is that revoking a token before expiration is more complex than deleting a session, often requiring a deny list of revoked tokens. Despite that complexity, shifting from memory-based sessions to math-based JWTs is what allows microservice architectures to handle high volumes of concurrent requests. In some cases, a backend developer may want to avoid the responsibility of managing user passwords entirely. This is the use case for OAuth 2.0. When choosing Login with Google, the user is rerouted to an external authority. Once identity is confirmed, Google issues an access token to the application, allowing it to retrieve user data without ever seeing the password. This delegation of identity management reduces the risk of password leaks and simplifies the user onboarding process. However, not all authentication involves a human user. Sometimes, two backend services need to communicate directly. For machine-to-machine communication, like fetching data from Stripe, the system uses API keys. These are long, static strings passed in the header to authenticate the automated data request. These keys represent the application itself, rather than an individual user, forming a separate security layer. While JWTs handle internal users, OAuth and API keys provide the standardized protocols needed to connect a backend to the broader internet. Implementing these concepts in a modern environment like FastAPI requires following a specific cryptographic workflow. The first step is user registration. FastAPI developers use libraries like passlib to convert plain text passwords into a cryptographic hash before they are stored in the database. This ensures that the actual password is never saved. The server only stores the result of the hashing function, which cannot be reversed to reveal the original text. Step 2 occurs during login, where the user sends their credentials to a specific /token endpoint. The server hashes the incoming password and compares it to the stored hash. If they match, a JWT is generated and issued to the client. This token contains the user's ID and an expiration time, signed with a secret key that only the server knows. The client receives this token and uses it to identify itself in all future requests. This process ensures that even if the database is accessed, the information found is mathematically useless to an attacker. With the token issued, the final step is to protect the application's private routes efficiently. In Step 3, the client attempts to access a protected endpoint, such as users/me, by providing the JWT in the header. FastAPI simplifies this using dependency injection. By using the depends function, the framework can automatically extract and validate the token before the route's logic is even triggered. In Step 4, the server uses its secret key to verify the token signature. If the signature is valid, the token provides the verified user ID to the application logic. If the token is invalid or expired, FastAPI rejects the request immediately, returning a 401 unauthorized error before any data is processed. This dependency injection model allows developers to secure hundreds of routes with a single, reusable validation function. The result is a complete, automated workflow, moving from secure registration to stateless verification. By combining the scalability of JWTs with FastAPI's dependency management, developers can build backend architectures where security is a verifiable, modular property of the code.